here's an example of a typical medchem route. Since I can't use any structures from my company, I went to one of my favorite papers, OPRD, and find a Japanese example. And the reason why I kind of like this is the molecule really looks like an API. It's definitely a pharma target. So what we're looking here is a very typical starting material for medicinal chemist. Extremely expensive, and the source article says that they paid this amount for it. But I took a price from Sigma Aldrich because generally we buy everything from Sigma Aldrich because that's the fastest way of getting material. And in here you can see fluorine, which is required for the later stages. We use a lot of chromatographic steps, and this is known for the production scale because you can't do that. Well, there are probably examples of kilogram chromatography in the world, but eventually you can't do that. Then these hazardous chemicals which might be toxic, and even recently one of the process chemists told one of the med chemists that you can't use sodium azide, invent something new, redesign your route. And eventually we're looking at kind of total 10 steps, and we get the material done. And I marked down the steps that is the expanding. So we're getting the medicinal chemistry idea of diversity. You need the fluorine because you want to be sure that the later stage that it works in every single time. Putting some other thing, you can make diversity. Putting another building, but more diversity, and an amide coupling, which is used by everybody still, and everybody's struggling with it, and it builds more diversity, so you get much diverse kind of a lot more huge amount of APIs or NCEs in this case. Well, what happens when a process chemist takes over? So starting material, a lot cheaper. I found an even cheaper price from a database than they claim in their original article. And the biggest issue, like you can see that precipitation, active extraction, evaporation. So they evaporate the dry, and that goes to the next step. And you see no chromatography. And although this particular example starts with a kilogram, it ends up in 200 kilograms. You can see the scale up is there already. So you can probably scale this up to a multi-kilogram or multi-ton operation. But I don't know what happened to this particular API from Meiji Seika Kaisha, and that's the other code. I think it's medicinal or some company like that. But there was also some issues in here. They use of course genotoxic impurity in this case. But the A side is also gone. So there's an amination, transfer amination, like hydrogen amination in here. And of course, in one case, they have a mixture of transesterification, but it goes to the next process, and they can still isolate the product in high yield. But this is a typical difference between the medchem and the process chem.